We are going back to the moon. As part of the Artemis program, NASA will return to the lunar surface in this decade to do scientific research. This will include in situ resource utilization, or using what is there to make what we need. At Texas State, we have been researching this goal for years. We are the Bobcat CaerusCrete team. Caerus is the Greek god of opportunity, and we see lots of opportunity in making concrete on the moon. As part of the NASA MINDS competition in 2023, the team focused mainly on the civil engineering aspect of the material itself. Last year's team researched geopolymer, which is an inorganic, highly polymeric material which is synthesized by the alkali activation of silica and alumina. It has several advantages over conventional Portland cement, including high mechanical strength, high resistance to radiation and temperature change, not to mention very good durability. It is a potentially locally produced material, as geopolymer concrete can be produced with water, alkali activator chemical, and lunar regolith. This year, students in manufacturing engineering, mechanical engineering, and electrical engineering collaborated to research and prototype the key component of a machine capable of processing this geopolymer in a lunar environment. Because the lack of air on the moon does not allow for liquid water to exist on the surface, and because the moon's 1/6 gravity may not allow bubbles the directional force to escape from a wet slurry, concrete cured there would be porous. So to get around that problem, the team devised a centrifuge designed to be housed in a pressurized containment. To take on this task, repeated computer-aided drafting iterations were designed in SolidWorks. Then these designs were tested with additive manufacturing or 3D printing playing a central role in the development of the lunar concrete mixer. The team used code and Arduino to program the motors, air pressure controls, and dirt ingress actuator. There was substantial manual labor involved as well. As the team was able to test new versions of the mixer, designs were improved to function better. Gears from the initial design were removed and replaced with 2 motors. Electrical actuators were replaced with pneumatically driven ones, and mold doors were replaced with tight-fitting pistons which served the same function. Various mixer blades were designed and likely will be tested in future iterations. In the current one, the liquid is designed to flow through the mixer blade itself, wetting and combining with lunar soil to make geopolymer. The idea is that first, the regolith, water, and activator would be mixed in a central chamber. Then, when ready for curing, the chamber would spin and give centripetal force to the drying concrete tiles. As the geopolymer cures, the evaporated water can be used to mix the next batch of concrete.
Right now I'm just pretty much giving the pump power to see how it sprays out the holes over here for applying the water inside the mixer and the activator. And it seems to work. Looks like we do have a little bit of a leak coming from up there, which is probably related to that. The bolt is going to have to redesign that a little bit. But
We have squirts.
it squirts. 5 seconds.
Gravity is the pin that is running the
motor that is plugged in.
the motor that is plugged in right now, and we're gonna turn it high and low.
So here we have a motor that runs on 12 volts here. In order to run the motor, we need some kind of motor driver. So here we have a chip. It's called the A4988.
Yeah.
And so we use a microcontroller that uses pulse width modulation from these pins to drive the direction and the strength at which the motor runs. Yes, and here's a 12 volt power supply, but the microcontroller and the chip run at 12 volts.
I'm measuring out the Arduino so we can try and make holes that hopefully will be in the right position once we get done laser cutting them to mount everything so it looks clean and pretty.
Yeah.
Water? Water? Alkali activator?
It should be doing that.
A squirt spray?
I mean, if you're saying it's not providing on the bottom,
Damn straight it does.
I imagine it should be taking over by itself by now with this gas.
Oh! Oh, come on. Come on, Bessie.
Kind of worked. So, are you planning on continuing to work on it and trying to get it to the fully worked stage?
Yes, so we are planning on doing that. So this version I have here that you can see, we also started including things of bearings in the center. That this one we have here, the one that we ended up submitting the video, and it was our main test for that. Just due to other delays in schoolwork and those sort of things, we weren't fully able to actually get it as nice as we wanted before the end of the cutoff date. So we've already started including bearings on the top and bottom for all the surfaces and 3D printing these in a different variety, along with making inserts for aluminum piston sleeves in there to cut down on some of the binding for the pneumatic operations.
So yes.
So we are planning on continuing with the project.
Yeah, I wanted to say I very much enjoyed your presentation. You guys had integrated a lot of different disciplines together, and we're able to troubleshoot different aspects of it. My question, so kudos for that.
The tensioner for that. But on the newer style that we have already started doing, where you're going to be seeing and using a pretty much a tracked, like 2 6mm standard size that you see on most like 3D printers, and potentially they have to go up to a bigger one. So we've learned from that initial failure on that while doing the testing, and are going to be switching to something along those lines because we did have so much of a slippage issue. So.
Yeah. Okay. And then one last thing. So, did you ever saw any actual content?
A lot in this project, and I'm understanding how to like hook up different devices that are not always given in class to power them and to give logic to. That's something we really learned through this project, and yeah.
Design, building, demonstration.
Don't be us. I want to be number one.
This award goes to the Luna
good.
Tips. So congratulations to the
All right.
It's like if you pay attention to his hands, you
Yeah, I saw the logo. I was like,
I saw red. I was scared.
oh.
All right.
Second place now.
All right. I'll take it.
Second place award for design, building, demonstration goes to
Look at the guy's hands on the left.
Bobcat.
Damn.
Okay.
I'll take it. All right.
That's
I'll take it though. I'll take it. Yeah.
Presentation here so we can see this. Right? Look at that.
Oh heck. Oh heck.
I think we get the whole trophy into the.
Oh, we don't get that.